Section 6.1, we're actually, like I say, we're going to cover 6.1 and 6.2, I've decided, because that way next week we can just focus on basically one topic, which is kind of the most important topic of the chapter. And so that will make next week, that'll make next week a little bit easier if we cover this preliminary stuff tonight. So 6.1, factoring out a greatest common factor. What we're doing in this chapter is kind of the reverse of what we just finished testing on. So last chapter, we were multiplying polynomials. Here, we're going to be breaking them apart into factors. So we're kind of doing the opposite of what we were doing. So hopefully, we'll be able to tie that together. First thing we're going to do is learn how to factor out greatest common factor. A greatest common factor is exactly what it sounds like. It has to be the greatest or the biggest thing that something has in common. So that's in both or all of the parts, and it has to be a factor. In other words, it's things that are multiplied. Okay, so I'm going to show you how this works. But the greatest common factor, the GCF, is the largest number that can be divided evenly into each other number in a group of numbers. And we'll use numbers, but then we'll also do variables as well. I left this on. Hopefully the batteries didn't get dead. All right, good. So looking at this, we're going to factor the GCF of these things. Now, I'm going to do this a couple of times just so you can see it this way, but I don't expect you to do this all the time on your papers, okay? So I'm going to break these things down as far as they can be broken down. Again, the first couple of times, but I don't necessarily expect you to do this when you're doing the homework. So 25. If we think about 25, 25 can be broken up into what times what?
5 times 5.
5 times 5. So this part right here means 5 times 5 times x times x times x times x. That's what that first one means, just by definition. Does that make sense? Okay, then we have a minus sign. And then 15. How can we break up 15?
3 times 5.
3 times 5. So 3 times 5. And then how many x's do we have?
3.
3 x's.
Do you be writing that down?
If you want to, just so you kind of see that example, you can. But do you have to? Like I said, you're not going to have to do that. Plus, now 20, that'll take us a little bit longer to break up. How do we break up the 20?
5 times 4.
5 times 4. And then the 4 breaks up into 2 times 2, right? So this is 2 times 2 times 5, and then 2 x's. Okay? So again, I don't expect you to do this every time, but I want you to get the idea of what's actually going on here. Once I have this broken all apart, what I want us to see...
Okay, why did you do, can't you do 4 times 5?
Yeah, but then we break down the 4 also. So we break it down as far as we can. Again, you're not going to have to do this every time. I just want you to see visually what's going on here. So notice, when we look at the number parts, what do you see that's in all 3 of these?
X's.
The number part.
Oh, there's a 5 in each one.
There's a 5 in each one. So this one has a 5 in it. It actually has 2. But this one has a 5 in it, and this one has a 5 in it. So 5 is the number that they all have in common. Does that make sense? That means we can factor out a 5. Okay? Now let's look at the x's. They all have some x's, right? But how many x's do every one of them actually have?
Like this.
2. They all have at least 2, right? So what we're going to do is we're going to say, okay, this one has 2, and this one has at least 2, and this one has at least 2.
You can't start by 1.
What's that?
You can't say 1.
You could say 1, but we want to take out, we're looking for the greatest amount of everything. So if there's 2 in all of them, we're going to take out 2 x's. So we're going to take out the x and the x. Okay? Now, after we have figured out what our greatest common factor is, we write down a parentheses. And now we just kind of put together what's left. So what's left in the first one is a 5 and 2 more x's, right? Everybody see that that's still left in the first term? And then we've got the minus sign. What's left in the second term? a 3, and an x. And then we have a plus sign. And then what's left in the last term?
You can't get the other two x from the first one?
These two? Nope. Because you can only take out as many as all of them have. So if this one has 2, that's your kind of your limiting one. This one only has 2, so I can only take out 2 from the middle, and I can only take out 2 from the first one. It has to be this. You have to take out the same thing from each term. But that's a good question. Because yeah, it's not that we're looking for pairs like we were doing before. You're just saying, I have to take out the same thing from every one, and there's no more x's to take out of this one, so we can't take any more x's out of these either. So what's left in that last term? 2 and 2. Okay. Now, the last thing that we would do if we do it this way is we're just going to make everything look nice, right? If we have 5x and x, we would write that as 5x squared. Okay. Notice inside we've got 5x and x again, so that'll be 5x squared. 3x, we don't have to do anything with that. It's just 3x. And then what would we put at the end? 4. So this is our, when we factor out the greatest common factor, this is what it looks like. Okay. Now I want to show you something. You don't, again, this is just to show you how what we just did in this chapter 5 is we're doing the opposite now. If you saw this on your test and it said multiply, what would you do? We would distribute, right? Okay, so let me use red here just so that's different. So if we multiply 5 times 5x squared times 5x squared, it's going to be 25x to the 4th power. And this times this will be minus, you're multiplying, 15x to the 3rd power. And then this times this will be 20x squared. Now notice what this is compared to this.
Oh, so now we can check our answers.
You can check your answers. What we are doing is we're dividing out rather than multiplying through the parentheses. We're just doing the opposite in this chapter compared to the last chapter. Okay? So in the last chapter, we were distributing. In this chapter, we're going to be factoring out, breaking it apart into its smaller pieces. Okay? But again, this is just to show you the relationship. This right here is our answer. That's factoring out the greatest common factor. Okay? Does that make sense for the first example? And I took a long time on this, so we won't do this long of a time this long of an explanation every time. But I am going to explain it one more time doing it this way, and then we'll shorten it up a little bit and look at some things that can speed this up a little bit for us. Okay? So looking at this one. Now, these numbers aren't too big. This is just a 3. But we have 3 x's, right? And 2 y's and 1 z. Is everybody okay with that on the first one? Mm-hmm. All right. Plus, we've got a 5, which we can't break up. And we've got 4 x's, 3 y's, and I should have started over further, 5 z's. And then minus, and then 4 we can break up into 2 times 2, and then x, and then 4 y's. All right. Once we've got that, when we look at the numbers first, do they have anything in common?
Sorry, I'm trying to write.
It's okay.
No.
No, they don't have any numbers in common, so we're not going to be able to factor out any numbers. How about let's look at the x's. Do they have any x's in common?
No.
They actually have 1, because this one has 1 x, so we're able to take out an x from there, an x from here, and an x from here. So we can factor out 1 x. How about y's?
Yeah.
How many?
2.
They all have at least 2 y's. So we are able to factor out 2 y's. And how about z's?
No.
No, because the last one doesn't have any z's, does it? Okay, so then we want to go ahead and write down what we have left. What do we have left in our first term after we factor out the x and the two y's?
3,
3,
x,
x and x,
z,
z. And then we're done with that one. Plus, then what do we have left in the second term after we factor out?
5,
A 5,
x,
3 x's. Looks like 1 y and 5 z's.
Yeah.
Okay, and then minus. And what do we have left in that last term?
2 times 2,
2 times 2,
y.
and then 2 y's. All right, and then again, what we want to do is we want to make this look nice. We don't want this all written out like crazy. So what would we write this green part as?
Well, x and then y to the second.
X, y squared. Perfect. Then we've got a 3, and then how would we write the rest of that first term?
X to the second,
X to the second,
z,
and z. And then plus, how would we write this one? 5.
x to the third, y, z to the fifth,
Correct. And then-
minus 4, y to the second.
Yep. 4y squared. Okay, and that one is done. Okay. How does that seem so far? Or are we still writing, since I wrote this out really, really long? I wrote a lot of writing on
But that's
these.
good though, because the,
I want you to visualize what's going on, because eventually we're not going to write it all out.
okay,
Like the next one that we do, we're not going to write all out. But I want you to see that we're looking at what do the numbers have in common, right? And in this case, there was nothing in common. When we look at this, notice we were able to take out 1x, right? Look at your exponents. This is x to the third, x to the fourth, and then x to the first. We are limited by the smallest number of x's, right?
Mhm.
So we can just look at the exponents and say, well, there's 3 here, there's 4 here. Oh, there's only 1 there. That means I can only take out 1x. Does that make sense? Then we look at the exponents for the y's. I've got 2 y's, 3 y's, 4 y's. So I can only take out 2 because this one only has 2. That makes sense? So that's why we were able to take out 2 y's, y squared. And then we look at the z's, and we've got 1 z, we've got 5 z's, but here we don't have any z's. So we can't take out any z's. Okay, so that's kind of the thinking. We can think of them, I mean, you can think of them as these groups, but you don't want to have to write that down every time. That would be a pain.
Mhm.
Okay, but I did it a couple times just so we can think about what it looks like.
You're so good.
All right, so are we okay to go on to the next one? Okay.
You're so good.
You guys are just trying to get out of here earlier, aren't you?
Yeah.
Okay, so notice we've got these. Let's see if we can do this without writing down all the stuff all spread out.
Did I miss one?
Do I have?
Oh, it's the last one. I just covered it.
Okay. So, looking at the numbers, what number do you think we could divide out of 21, 14, and 7?
7.
Do you see that 7
Oh.
divides evenly into each of those?
Mhm.
So we are going to factor out a 7. So right now I'm just going to write down that factor on the outside like we did before. I'm just not going to write everything down to visually to see it. Okay? Then we've got x's. They all have x's. So how many x's will we be able to factor out?
1.
1x. So we're going to factor out a 7 from each of these and an x from each of these. And I do want to emphasize, we're doing the opposite of what we just did. We're dividing this out, right? Factoring is dividing out. So this is what we're going to factor out. If we take a 21, I'm going to start with the number part. If we take the 21 and divide by the 7, what's going to be left?
3.
3. Is everybody okay with that? That we're dividing out the 7? So 21 divided by 7 is 3. If we take the x cubed and we divide out an x, what's going to be left there? if you want to think about the groups, how many x's do we have here?
2.
That's the answer. We have 3. We're factoring out one of them, right? So we have 2 left, x squared. Does that make sense?
I think I'm gonna like writing it out.
You're going to like writing it out?
I don't know.
Well, and you might want to. But as you see it, you might also
Yeah.
get better at this too.
Yeah.
All right. So then we go to the next term. 14. We're dividing out a 7. What number is going to be left?
2.
2. And then we've got x squared, and we're dividing out an x. What's going to be left there?
X.
Just one x.
One.
Okay.
Oh, sorry.
And then and then she's anticipating the question. We've got 7. We're dividing out a 7. What's going to be left for the number part? 1. And if you want to write it down, that's fine. If you don't want to write the 1, we've still got some x's to look at. But this one, when we divide out an x from the x, what are we going to have left there? What's x divided by x? Still just 1, right?
Oh.
So I don't have to write the 1 again because we know 1 time, it would just be 1 times 1, which is just still 1. Okay. And so that stays as a 1. Now, that one is probably the trickiest one that people mess up on. They're like, oh, there's nothing left. I took out a 7x. It's gone. But you got to remember you're dividing. So 7x divided by 7x is 1. Anytime you divide something by itself, you get 1.
1.
Okay. And again, if you want to check, if we distribute, 7 times 3 is 21. X times x squared is x cubed. 7 times 2 is 14. X times x is x squared. 7 times 1 is 7, and then x, so 7x. So you can always check by doing what we just did in chapter 5, by multiplying it back out. Now, I'm showing you this. If you're more comfortable writing out all the pieces, you can certainly do that, especially as you're starting. But hopefully, eventually, we'll get to the point where we can kind of visualize and just do it a little bit quicker. Okay? Are we okay to go on to the next one? Any questions? All right, let's go on to the next one then. So again, let's figure out what our GCF is. The GCF is the part on the outside that we're able to factor out of each thing. So let's look at our numbers first again. What number do you think that we could factor out of each of those numbers, the 12, the 6, and the 8?
2.
Yeah, just a 2. Does that make sense? A 2 will divide into every one of those, and that's the biggest thing that divides into each of those. Then let's look at the x's. How many x's can we factor out of each term? A total, you can factor out 3 because this one only has 3 to factor out, right? So x cubed. Okay, and then we look at the y's. You just look at each part kind of individually. How many y's will we be able to factor out of everything?
2.
Out of each term? 2 of them, y squared. And that's because this one only has 2 y's. So that's going to be our greatest common factor. That's our GCF. And then we put our parentheses. And then we think about what's left after we divide this out. So let's start with the number. What's left when we take the 12 and divide out the 2?
6.
6. Okay. Then look at the x's. You've got x to the 5th. You're dividing out x cubed. So what's going to be left? X squared. Right? You've got a group of 5. You're factoring out 3 of them. So x squared. And then what's left when we take the y squared and we factor out a y squared? Yeah, it's a 1, but we don't have to write the 1 because when you multiply by 1, nothing happens, right? That makes sense? All right. Then we put our minus sign. We go to the next term. 6. We're dividing out a 2. What's going to be left there? 3. Then we've got x to the 4th. We're dividing out x cubed.
Okay.
So just being x. And y to the 4th, and we're dividing out y squared.
2.
y squared. 2 of them are left. Okay. Then we're going to go to our last term. We've got an 8. We're dividing out a 2. What's going to be left? 4. And we've got an x cubed, and we're dividing out an x cubed. What's going to be left there? It's again, it's a 1, but we don't have to write it down because it'll just be 4 times 1, which is still 4. And then we've got y to the 5th, and we're dividing out a y squared, y cubed. And then we get to the end, and we're done. Couple things to notice. After you factor out the greatest common factor, notice how many terms we have. 1 term, 2 terms, 3 terms, right? How many terms did we have at the beginning? 1 term, 2 terms, 3 terms. You will still have the same number of terms inside your parentheses that you had at the beginning. It's just that you've taken out what they had in common, so that that's going to be on the outside. But there's still going to be the same number of terms because you're dividing. And so the smallest thing you could get in here would be like a 1 if you were able to factor out everything. So it'll still be there. It just will be smaller than it used to be. Okay. What do you guys think about that particular example? Is that getting easier to just look at it and picture what's going on? A little bit? And that's what happens. You start practicing, you're going to start seeing it a little bit easier, hopefully. Any questions before we go on to, is it the last one?
Yeah.
All right. Let's take a look at this one. Let's look at the numbers first. What number do we see that can be divided evenly into each of those?
9.
9?
But I do have a question.
Yeah.
So is it always going to be divisible by a number?
You always, no. Remember the second one we did where it was a 5 and a 3 and a 4, I think? And there was no number that we could divide into any of them. Then we just skipped the number part. Do you see what I'm talking about? I think it was the second one we did, right?
Mm-hmm. Oh, yeah.
Okay, and then we can't factor out any number.
Got it.
A lot of times there will be a number, but not always. Okay, but yes, you're right. A 9, we can factor out a 9. So let's write down the 9. And then so that's the number. How about the a's? What will we be able to factor out of each of these?
2.
A squared. And then we look at the b's.
3.
B cubed. All right. Okay, so then we have figured out our greatest common factor. That's this outside part, greatest common factor. What will be left when we look at the 18 after we divide out the 9? 2. What will be left with the a's after we divide out the a squared?
A squared.
A squared, because you had 4 of them, now you have 2 left. Is everybody okay with that? And what about the b cubed after you divide out b cubed? It's 1, but we don't have to write it because it's already, nothing changes there. Okay, minus. We look at the number again. The 27 divided by the 9,
3.
a 3. A cubed, and we're dividing out a squared.
1.
We're just being a, 1a, a to the first power. And b cubed, we're dividing out a b cubed. Just a number 1. So again, the 1 doesn't change anything. Plus. All right. 9 divided by 9.
1.
1. A squared divided by a squared.
1.
1. B cubed divided by b cubed. 1. So this time we do have to put the 1 there because that's all that's there. Right?
Mm-hmm.
So anytime you're taking this term and dividing out all the parts of the term, you're going to end up with that divided by itself is going to be 1. Okay, notice still 3 terms. We started with 3 terms. Okay. And that is really all there is to factoring out a greatest common factor. Okay. What questions do you have?
Can we go home?
Not yet. Oh, it's only 8:45. It's getting too late. It's getting to be bedtime. Okay.
When's the-
Any questions on that before we
Move on?
move on? So there are 5 problems like that. And really, you want to be able to do that because that sets the stage for what we're going to do right now. So let me switch this over.